Thank you very much. Yeah, I didn't know you were gonna give such a creative input to the introduction. I was surprised there. Right, so the talk indeed today is about interacting with a billion records using semi-autonomous agents. And we can see this talk a little bit like a report on things we ran into when building a product at Data Provider, which is the company I work for. We are in Groningen. You might have seen this sign, which we've been there longer, but the sign's been only up 1 year there. It's when you drive down the Europaweg. I don't know how many people are from Groningen, but when you drive from the Europaweg and you're about where the Euroborg is, you might see that. So you drive, my name is Tim Kreutz. I am a machine learning engineer there at Data Provider. And recently, or the last year or so, that job description has been a little bit more loose because we've also started using LLMs in ways that sometimes makes me doubt how much of a machine learning engineer I still am and how much of a sort of agent whisperer I've become. The talk then is about something that we started building, but I'll try to separate it as much as possible from our own specific context, because generally I think there are lessons to be learned here about interacting with a lot of data through an LLM, data that is not readily available to an LLM because the LLM reads whatever books the internet, but we are talking specifically about structured records, so huge databases. And how can an LLM know about the records that are in there? I'll start with the context of this project specifically for us, but also how you might think of this separate from our use case. It's already in the title, but we will break up the problem with agents that we found were definitely necessary here to be able to do this. And then finally, and this is the most recent work we've been doing on this, sort of the implicit behaviors that happen when you choose or not choose a multi-agent design pattern. So how the agents talk to each other and what gets lost in that translation. First, the context. So we are a data company, which means we have a lot of data, and the data specifically is about the web, so the internet. And at its core, we store records on the level of a host name. So a host name is that part that is the subdomain, the second level domain, and the top level domain here. And that's kind of the center of our record. And about that record, we try to save basically as much information as we can extract. So you would have something like this, where at its core, as its unique identifier, we have host names. This could be like www.google.com. And we try to save as much information about that. So this could be content information, like the topic of a website, keywords that were extracted, and here's where the machine learning bits kind of come in, which company might be behind the website, and information about that company, so business information we also try to have. And then, not to be underestimated, there's a lot of technical information that we can find out about these host names. And this technical information specifically is something I want to focus on, because when you look at the possible fields that you have for a record, these are also not things that are maybe easily explainable. Maybe in this room that would work. I could say, so we have IP information, and you would know, like, okay, that's something. Or we have DNS information, and you know kind of what that is. But more often than not, we talk to people who don't have any idea about how the internet works, but we're still trying to communicate with them why it's useful to get this data. So it's a lot of domain knowledge inherent in it. And this is also where we let the context of Data Provider kind of go, because all you need to really know for this talk is that we have this huge data, billion records, as I said, that's in volume, but also in dimensionality we have like now close to, I think, 300 of those fields, that including beta fields and all that stuff. So that might each of them be very hard to explain, just like that. And because it's so hard to explain, it actually makes sense to develop something that can talk to this data, because without understanding the data, you can kind of probe it to just find out if it's interesting for your use case. So if you are a company, it's much easier to understand a chat interface in which you can just ask sort of the use case you're interested in, instead of having someone describe, well, this is huge data and it's interesting data and you should want it. It's much nicer to be able to ask it these kind of questions just directly. So that's kind of where we are coming from. But generally, this requires a solution that can talk to a lot of structured data. So it's also more generally applicable here. Obviously, this information, the data itself, can never be just inserted into a prompt. That's also not what prompts are for. But even in the dimensionality, so all this information about what is a DNS server, what is IP, all of this would also make for too big of a prompt to kind of get all this knowledge in there. So we're looking here definitely at like an agentic approach to breaking down this problem and kind of doing it stepwise. And I'll talk about 3 of the agents that kind of are the key there that we found. And how they kind of distribute the work. So the first is, as I kind of already said, in this dimensionality, there's a lot of knowledge inherent. Like, you need to be able to understand the internet to be able to answer a question that might go into a system like this. And a knowledge agent is basically the mechanism by which you say, well, now that you've asked this question, I know what it's about. And I know the information that you require to answer this question. So it's an agent that is able to get only those pieces of knowledge that are required to answer the question, and also to know where you might find the data in our system. So how we've done it is we've had an LLM basically query a vector database, which is our internal knowledge base, and then retrieve, well, here it says 3, but we've tweaked with that a little bit, retrieve the top documents that are relevant for the question. So you can pass them downstream and say, like, this seems to be a question, for example, for the WordPress websites in Groningen, this seems to be a question that might refer to a province, Groningen, or a city, Groningen, both of which we have information about. And you're also asking about WordPress, which in our knowledge base turns out is a content management system. So at this point, what I'll load into the downstream will be 3 documents. One explaining what a CMS is, and which fields that data provider has are about CMSs, and how you can find city information, how you can find province information. So first, this happens. Then, since we are working with structured data, there is a need for a specialization of creating queries based on the information that you had earlier. So a dedicated agent that will say, okay, you're meaning to talk to this data. I know the language which is needed to talk to this data. And here I made an example of so these prompts normally, like, this is not in production. They're much longer and I've kind of cut them off. But for example, this is an agent that would be specialized in query DSL for talking to Elastic, and which we can give some tools to, with which it can basically verify that the DSL that it has generated is valid syntax. But also, if we've passed it from the previous step, look into the city, look into the province, and look into the CMS to check whether those fields are actually valid as well, whether they are present. You can imagine, for example, a question going in there that is just impossible to answer, like who is the boss of this company? what it would do is try to maybe guess that there's a field called boss in the database. It will create that query, and it's a valid query, but we have an endpoint to check whether boss is actually something that you can find from our data, and it would tell you that you should probably not go down that road. This is not the query you wanna do. And then finally, there's this layer that we've put on top of many of the API endpoints that we have ourselves, which are just operations that can happen on the database. So now we have a query, and we might want to aggregate all the data from a certain field, or we might want to count certain values. And for this, we have the orchestrator agent who kind of plans out the steps one by one that are needed to answer the question, and then has access to most of the tools of any of the agent, because these are all the tools that are already available in our API. So a very common one is to just look up something. If you're requesting a specific company, for example, to look into the company field and check the name, or to aggregate, do a count if you want to know the number of WordPress websites in Groningen. There's a sort of separate endpoint for getting traffic information, so the number of visitors to a website. You might just want to know what are the most popular values in the field, and others, but there's many more like this. So these three, I think, are the core of breaking down the problem in a way that it becomes manageable to talk to 1 billion records. And what we kind of didn't foresee is that after dividing the task, that now comes a question of how do these agents interact with each other. And in a first setup, we just kind of assumed that we understood the sequentiality of these steps, right? So this is also the order in which I presented them, to first find out what knowledge is necessary from the knowledge base to answer this question, to kind of like bring it back to just the essentials, then to generate a query, and the query is usually necessary for the orchestrator to run the commands that you need to get the data. So we thought there was a very rigid order that we needed to keep into account, and we came up with a first system that was a little bit like this. So I explained about 3 agents. Obviously, there's many more things we wanted to have happen, but they're not really the core of it, like generating follow-up questions, or a specialized agent that would answer, is this question answered properly, and would loop back. But the important thing is that we look at this and we kind of recognize it as a classic pipeline design. And so usually there's a single arrow going from an agent to the next. So there's a handoff happening where the agent has to run their operations, has to have some sort of output, could be a JSON output, that would be picked up by the next step and then go downstream like that. And we thought that made sense because we thought that each step was sort of necessary to go on and do the next. But, well, deploying this, we are happy with definitely answering questions like this. So this is in our system. You can see that under the reasoning, you very rigidly get these sequential steps that it will always do when you ask a question. And at the end of it, it will have looked at the province of Groningen, at the city of Groningen, and at the WordPress CMS, and have an answer for you. And this is right, because this is not a question that is necessarily that hard for it to answer. And we only started doing a double take when we, simultaneously to developing this pipeline, also thought, well, we have these tools, and there is such a thing as the model context protocol. So why not just expose them and then see how far something like Claude would get, but only using the tools. So we put a lot of time in making the perfect prompts and tweaking those, and then saying, well, you have to definitely find knowledge out first. Then you have to generate a query, and then you have to run these tools, probably in the order like this. But when you ask Claude and you just expose the MCP, it comes to the same answer when you don't really tell it to do things in a certain order. So all that boilerplate and all that stuff, at least for the easy questions, it's smart enough to kind of decide the pipeline by itself. And without really having specifically chosen for this, with the pipeline in mind, we kind of made a decision about where we wanted to be on a scale, and there's many dimensions in which you can kind of divide multi-agent design. But when you look at the MCP, it can definitely be it can be called more of an autonomous system. So there's one brain, and it has these tools, and it can use them in whichever way it sees fit, based on their descriptions. And it does actually pretty well. And what else we noticed is, at this point you have fewer agents, and calling the tools doesn't take that long, so you have faster answers. And it only makes the essential calls, because when it runs a tool, and then at the other end of it has an answer to your question, that's it. So there's no need to necessarily run every step in the pipeline and hand off the result. And for questions that were kind of debatable whether the answer was really present in the data anyway, it would come up with answers. I tried to spin it a bit more positively, higher creativity. But basically it would always come up with an answer. And sometimes a customer would use it and would look at the answer thinking, well, that's not right. But it is an answer. It is something that I didn't know. It's something that is kind of in the context of my question. So it's kind of nice to have. When our pipeline would probably crash and say, I'm sorry, but there's no such field. You asked for the boss of this, but I have no idea how to answer that, which is also nice. So on the other end of the spectrum is our sort of decision we didn't really make, but kind of was the effect of having put things into a pipeline, which can be called the sequential agent handoff, where you have many agents, but there are few tools defined per agent, so less autonomy, and you have to run every step. And the nicer thing, because we are a data company, of course, is that you do find there's more determinism, so higher consistency, and the answers that you get are actually factual, and probably you don't get an answer about something that is not in the data. Now, is this necessarily a thing you have to choose, left or right? No. We realized that we had been a little bit too strict about which steps definitely needed to come before other steps. So the considerations, and I hope these are a little bit more generally applicable in such situations, is what balance do you want to strike for your application? Is it more important to come up with a question, or is it more important to come up with a answer, or is it more important to come up with a right answer that can take a while? And we also realized there are questions that we didn't think to ask it. And this is something you notice in production, of course, when people start actually using it, that kind of lay bare that the sequentiality that we put into it wasn't always needed. So we have this knowledge-based step, which always is followed by a query generation step, which is always followed by a orchestrator. But if someone simply wants to know, because we are the experts of the internet, what is a domain name server? Or maybe it's based on the previous answer where it said, well, I have some name server information for you here. And then someone would ask, well, what is a domain name server? This is something that can purely be answered by querying the knowledge base. Similarly, if you are being very exact in what you want to know, like how many different countries are represented in your database, this is something that when you know that what they're really asking is just summarize this field that you have, it's not really necessary to be an expert query generator. So, yeah. There's also the question of adaptability of the pipeline. And then what really is the conclusion of this is that I gave you this sort of definition of these are tools and these are agents and these are the pipelines that we have. But the fluidity of those concepts can be much more fluid, because if you say, well, the knowledge base itself is a tool you can use, or the agent is a tool you can use, or a subset of the pipelines is a tool you can use, then you end up with a system that can have these sort of deterministic steps, these sequences, but only when it's really necessary. So for example, for most of these questions, we want to follow a data workflow, but you can ask or make a delegation agent basically say, I decide when a data workflow is needed, but I also have just direct access to all these tools that might already be enough. And then within the colorful backgrounds, you have these sequences that need to have happened to get to the best answer. But if you go down, there's all these tools just available, so it can rearrange them however it sees fit. And it's an approach that kind of stands above it, because we do want the determinism that we had in the earlier steps, but we maybe don't want to enforce it to always do every step for every question. And so kind of to see agents themselves and the workflows, the sequential steps that are needed, as tools that can be picked at any time and in any order. This is something we're still working towards, so I don't have any results, unfortunately, on where it falls with regards to how it answers the questions, but it's something we might have next year. Thank you for listening, and still time for questions, I guess.
Thank you for your talk. It's very interesting. I'm just wondering, so if you have different configurations, did you check how did you check how it functions? Do you have a data set with results or something? So how do you assess what the quality of a configuration is?
This okay? Yeah. Thank you for your question. It's definitely important when you have so many steps to, at every step, kind of check. We've done that by hand in the early stages, and now are setting up this sort of end-to-end evaluation system. But for some of the steps, particularly the ones that have more discrete outputs, like the queries, for example, where you know how to find out the information that you need, these are things that we want to build the evals for, that ultimately say whether the step itself works or whether the agent works. Yeah, so the end-to-end thing is happening first, because when evaluating systems like that and multi-agent design, there's so many possible configurations that you just want to see build in some metrics that kind of reflect, do you ultimately get the right fact? How many other contextual things are being brought in? Those kind of things, yeah. Yeah, it's ultimately how you get a handle on, do these things work or not? Yeah.
Thank you. To follow up, so what do you do when you get an incorrect answer? How do you fix that?
Thank you. Yeah, that's very. We definitely had many times that it came back to us as having an incorrect answer. There's something interesting. So I'll answer it in two parts. So when you get an incorrect answer, usually it was an easy tweak somewhere, and with that I mean usually in the prompts. So it would be a kind of an obvious mistake. It made a query that doesn't exist, so you have to enforce that it doesn't create a predicate in this sort of nested way or something. The other thing is that we found in a multi-agent workflow that the responsibilities of the agents are sort of overlapping in places. So the knowledge base entry that we might get already shows the fields that are needed to answer the question. But then the query generation step also has examples of queries, so of some of the fields that it might use, and a list of those fields as well. So together, they kind of can repair each other's behaviors. This is something we found. This isn't really an answer to your question. Usually we would just go back, look at the obvious thing that went wrong in one of the steps, so we would in between check what was being sent, and fix that.
Anyone else? Questions?
Yes, thank you for your talk. I had a question. Do you have a preferred LLM or system you use, and how do you complete of use new versions of it? So every time OpenAI has new one or something.
Yes, we get very excited when this happens. So the move to GPT-5 was kind of an exciting thing, because I think it's sort of self-corrected when answers were a little bit easier, that it didn't always need to use the hardest thinking model. So it does that itself, of course. And then we kind of try to handle the rule that when the step is more reasoning oriented, we would go with better reasoning models, for example. But right now we kind of have this distinction that most use cases is GPT-5. And then some use cases we might use a Anthropic model or 4.0 mini for easier sort of decisions. So we have a simple agent that defines the title of the chat, for example. We can use a smaller model. Or we have a sort of decision to make, an agent has a decision to make whether clarification questions should be asked before answering the question. That's also a smaller model. Yeah. So we'll look a little bit at the workload of the agent.
Thank you.
So you have a lot of tools that you use for multiple agents. How do you test that the correct tools are used at the correct time, and not that it is skipping certain tools, or that it just calls random tools or whatever, and then uses the answers from those tools correctly and not hallucinating interesting answers?
Yeah, it's a little bit. Thanks for the question. It's a little bit the same as before. Like, how do we evaluate each step? And there's usually through the end-to-end testing, you get the idea that something went wrong. Obviously, after that, it's still tracking like what it does, for example, with these tools and the order of these tools, and using input of one tool for another tool. Yeah, but there's more to be done there, because I think planning tools, for example, is another case in which you can actually check very exactly if the steps are right, and if the tools are right, and if the inputs are right. So these are evals we still want to build, like before an agent and after an agent, and kind of see whether the tool planner is doing the best it can, or yeah.
Thanks.
Who would like to ask a final question? Yes.
How many tools do you currently expose to your agents, and did you? Because I noticed that the more tools you expose to your agent, the dumber it tends to get. How do you handle that, or do you just limit the amount of tools that you make available?
The number is definitely not up to a point where it gets dumber with what we use. Also because they do have very distinct sort of operations that they do, and they're not easy to confuse. But I think we use, and I'm using now the exact, like the strict way of talking about tools, as they are like sort of API operations with us. I think they're like 10 or something. I'm just also looking, yeah, but those are very distinct reasons to exist. It's not like look in this database or look in this database. That those are separate tools. Yeah.
Okay.
Thank you very much for this very insightful talk. A big hand of applause for Tim Kreutz.